Okay. Question 1, we have to evaluate 2 root 28 minus 3 root 50 plus root 72. Okay, so to simplify this, the first thing we'll need to do is we need to rewrite everything in simplest form, right? So we need to simplify all of the surds, yeah? So this is 2 root 28 minus 3 root 50 plus root 72. Right, so this would be 2 times, now root 28 can be written as root 4 times root 7, then minus 3 times root 50 can be written as root 25 times root 2. So the perfect square in 50 is 25, right? And then root 78 can be root 72 can be written as the biggest perfect square there is root 36 times root 2. Right? So this would become 2 times root 7 minus 3 times 5 times root 2 plus 6 times root 2. So we'll have 4 root 7 minus 15 root 2 plus 6 root 2. The final answer will just be 4 root 7 minus 9 root 2. Okay, so that's option C. Option C. So we just simplify the surds, ensuring that we have written everything in the simplest form, and then we just took it from there. Right, question 2. Root 20 times root 5 times root 5 times root 5. All right, so root 20 is square root of 4 times square root of 5. So when you simplify that, because 4 is a perfect square, so you want to separate that, then times root 5 raised to the power of 3. So this will be 2 root 5 times root 5 raised to the power of 3. So this will just be 2 root 5 raised to the power of 4. Okay, so root 5 raised to the power of 4, this will be 2 times, we could write it as 5 raised to the power of half raised to the power of 4. This will be 2 times 5 raised to the power of 2, right? Because the law of indices says that you multiply half times 4, right? So that rule says that a raised to the power of b raised to the power of c would be equal to a raised to the power of bc. So if you raise an exponent to another power, then you multiply the two exponents. So I'll end up with 2 times 25, which is just 15, right? So it's always safe to convert from surd back to, it's always very safe to convert from surd back to exponent form. It kind of makes you do very neat math. Yeah, just in case you're confused. So the answer is 15, C. But you could have walked straight from the surd form though, right? Because if you know that root 5 raised to the power of 2 will give you 5, then that's just raised to the power of 2 again, and then you're good. Okay, question 3. Question 3, we have square root of 128 plus square root of 18 minus square root of k is equal to 7 root 2. Find k. Okay, so I'll simplify everything I have on the left hand side first. Square root of 128, I can break it up into square root of 64 times square root of 2. This I can break up into square root of 9 times square root of 2, then minus square root of k is equal to 7 root 2. This will be 8 root 2 plus 3 root 2 minus k is equal to minus root k rather, right? Is equal to 7 root 2. Right, 8 plus 3 is 8 plus 3 is 10. That's 10 root 2 minus square root of k. Sorry, 11 root 2. 8 plus 3 is 11, my bad. That's 11 root 2 minus root k. Is equal to 7 root 2. Right? So I can collect like terms, right? Move k over to the right side and move I'll move 7 root 2 over here, and I can move k over here. Basically end up with, let me do that here. Basically end up with 11 root 2 minus 7 root 2 is equal to square root of k. So this gives me 4 root 2 is equal to the square root of k. So to get k, I can just square both sides. So this will become 4 squared times root 2 squared is equal to k. So this will be 16 times 2 is equal to k. K is 32. K is 32, that's option A. Okay, great. So question 4 is same as question 3. Question 4 is same as question 3. So we'll just keep that and then move to question 5. Question 5 says, given that root 3 plus root 5 over root 5 is equal to that, find the value of x plus y. Okay. All right, so we're going to rationalize what we have on the right side of on the left side of the equation. All right, so whenever you have a surd with an expression with a surd as the denominator, right, you want to rationalize that, and well, for this kind, we just multiply top and bottom by root 5, all right, to perform that simplification. So let's do that. So this is root 3 plus root 5 over root 5. So what I'll do here is I'll just multiply the top and the bottom by root 5. All right. So in doing this, we haven't really changed the value. The value is the same because we're multiplying by 1. But what this does for us is that we take advantage of the fact that the root 5 times root 5 will make the denominator to become 5. So we have that surd thing out of the denominator, right? And then we can now battle for the numerator. So root 3 times root 5 will give me root 15, plus root 5 times root 5 would give me 5. Okay, and so we are trying to make this become x plus y root 15. So I can rewrite the left hand side now as 1 out of 5 root 15 plus 5 out of 5, which means I can further reduce this to 1 out of 5 root 15 plus 1 plus 1. So when I compare this to x plus y root 15, by comparing this, it's easy to see that y is 1 over 5. I mean, you can see, right, the coefficient of root 15. All right, so y is equal to 1 over 5. And then x, the constant term, x is 1. All right, so x is equal to 1. So that means that x plus y, which is what we are asked for, would simply be 1 plus 1 over 5, 1 whole number 1 over 5. 1 whole number 1 over 5, that's option C. Okay, scroll down, question 6, we have that. Let's see, we have 2 raised to the power of a is equal to the square root of 64, all right, and b over a is equal to 3. Evaluate a squared plus b squared. So this is where we're going to. Okay, so 2 raised to the power of a is equal to the square root of 64. This is an exponential equation, all right. So we can solve this. So that means 2 raised to the power of a is equal to 8, right? 2 raised to the power of a is equal to 2 raised to the power of 3. All right, so if what we have here, if both sides are equal and the base number, that's the 2, right? The base number is equal, that means the exponent also has to be equal. So you can just, by that say a is equal to 3. So we have the value of a. Now we can come to the second bit of the equation and say b over a is equal to 3. So if I substitute what I had from a from the first side, I would have b over 3 is equal to 3. That makes b equal 9. That makes b equal 9. Therefore, we're nearly there. So we have the value for a and b. Now we can solve for a squared plus b squared. That would be 3 squared plus 9 squared. 9 plus 81, which is 90. B. Question 7. If k root 28 plus square root of 63 minus root 7 is equal to 0, find k. So the first thing we do with questions like this is that we just, reduce it and then see what comes out. So this will be k times square root of 4, because 4 is a perfect square that we can find in 28, right? Times square root of 7, right? So we've reduced root 28 to root 4 times root 7, plus we can do the same here. The perfect square we can find in 63 is 9. So root 9 times root 7 minus root 7 is equal to 0. All right, so this would be k times 2 times root 7 plus 3 times root 7 minus root 7 is equal to 0. So 2k root 7 plus 3 root 7 minus root 7 is equal to 0. So 2k root 7 plus 2 root 7 is equal to 0. I can move, collect like terms, that's move 2 root 7 over. So I would have 2k root 7 is equal to minus 2 root 7. And I can now divide both sides by 2 root 7. All right, so at this point, 2 would cancel out 2, root 7 would cancel out root 7. And here, this will cancel out that. I'll be left with minus 1, right? So k is equal to negative 1. That's D. So question 8. Question 8 says, if root 2 plus root 3 over root 3 is simplified as that, find the value of m plus n. Okay, so when we have questions like this, the first thing we want to do is rationalize that, right? And see how we can simplify it to figure out the values of m plus n with 6, right? So let's do that. So I'll take this. This is 2 root 2 plus root 3 over root 3. So to rationalize this, I'll multiply top and bottom by root 3 over root 3, right? And if you think about it, we are not changing the value of what we had before, because root 3 over root 3 is 1, and anything multiplied by 1 stays the same. So what we're really doing is we're just taking advantage of that trick to get rid of the surd, all right, in the denominator. So if we do that, we would have root 3 times root 3 would give me 3. So the denominator is sorted. Now for the top, would have root 2 times root 3 would give me root 6. And then root 3 times root 3 would give me 3. That means simplifying this, I can rewrite this as 1 over 3 root 6 plus 3 over 3 can still be written as, let me complete this here, 1 over 3 root 6 plus 1. So comparing it to this, right? So just look at this, right? Comparing this to m plus n root 6, it's obvious that m is 1. All right, that's this standalone, right? The constant term, if you will, or the integer, because the order is still a constant. And then n is 1 out of 3. We are asked to find m plus n. M plus n would be 1 plus 1 over 3, which is 1 whole number 1 over 3. That's option C. Okay, question 9 says root 50 is equal to k root 8. Sorry. Root 50 minus k root 8 is equal to 2 over 2 root 2. All right, so find the value of k. So let me write this out and then we just, simplify it to start with. So we have root 50 minus k root 8 is equal to 2 over root square root of 2. So we can simplify both sides. For this side, we'll just do the regular simplification, right, for the left hand side. But for the right hand side, we'll simplify by rationalizing, getting rid of the root at the bottom. All right, and then we can now compare and see what we have left. Okay, so let's start. Let me do the right hand side. All right, 2 out of root 2. We'll rationalize by multiplying both top and bottom by root 2. Again, we haven't changed the value of 2 over root 2 because if you think about it, we are really just multiplying by 1. Root 2 over root 2 is 1. All right, but what this has done is that it has helped us get rid of the roots in the denominator. So we'd have 2 root 2 over 2, which simplifies to just root 2. All right, because this 2 cancels out. Okay, so I can rewrite this as root 50 minus k root 8 is equal to root 2. So root 50 can be simplified to say square root of 25, because the perfect square we can find in 50 is 25, times square root of 2, minus k times the perfect square we can find in 8 is root 4, then times root 2 is equal to square root of 2. So we have 5 root 2 minus root 4 is 2, 2 times k is 2k, so that's minus 2k root 2 is equal to root 2. For that like terms, if I move 5 root 2 over, I'll have minus 2k root 2 is equal to root 2 minus 5 root 2. Okay, so now I'll say minus 2k root 2 is equal to, when I simplify this, I would have negative 4 root 2, because that's 1 root 2 minus 5 root 2, which is negative 4 root 2, and I can just go on and divide both sides by negative 2 root 2. Right, so let's do the cancelling carefully. Root 2 takes out root 2, negative 2 takes out negative 2. Here we're left with k. On the other hand, root 2 takes out root 2, and then negative 4 divided by negative 2 will give you positive 2. Right, so the answer here is B. Okay, question 10. All right, so root 24 plus root 96 minus root 600 is equal to y root 6. Okay, so we'll just simplify, right? Simplify the whole thing and see, what pops out if we're able to find the value of y. So root 24 plus root 96 minus root 600 is equal to y root 6. Okay, so what perfect squares can we find in each of them? All right, so in 24 I can find 4, right? 4 is a perfect square, so this will be root 4 times root 6 plus, in 96 I can find 16, right? So root 16 times root 6, and in 600 the perfect square, the biggest perfect square I can find is 100, right? So minus square root of 100 times square root of 6 is equal to y root 6. Simplifying that, here I would have 2 root 6 plus square root of 16 is 4, so that's 4 root 6 minus square root of 100 is 10. 10 root 6 is equal to y root 6. So 2 2 root 6 plus 4 root 6 will give me 6 root 6. So 6 root 6 minus 10 root 6 is equal to y root 6. So this is minus 4 root 6 is equal to y root 6. And now I can divide both sides by root 6 to get the value of y. My y will just be negative 4. That's option C. That's option C. All right, question 11. Square root of 72 plus square root of 32 minus 3 root 18 is equal to x root 8. Find the value of x. Find the value of x. Okay, so all we'll do is we'll simplify everything, see what pops out, and then I'll see how we can, manipulate to get the value of x. All right, so we have square root of 72 plus square root of 32 minus 3 square root of 18 is equal to x square root of 8. The square root of 72, the biggest power square number I can find there would be 36. So square root of 36 times square root of 2 plus, in 32, the biggest power I can find there is 16. Minus 3. Here I can find 9. And 8 I can find 2. All right. In 8 I can find 4. So the biggest square number I can find in 8 is 4. All right. So next step, this would become 6 root 2 plus this would become 4 root 2 minus okay, so root 9 is 3, so 3 times 3 is 9, so minus 9 root 2 is equal to, here I would have 2x square root of 2. Yes, 2x square root of 2, because root 4 is 2, so 2 times x is 2x, then root 2. Okay, so simplifying, the left hand side, I would have 10 root 2 minus 9 root 2 is equal to 2x root 2. So this would just be root 2 is equal to 2x root 2. To find the value for x, I'll divide both sides by 2 root 2. All right. So these guys will cancel out. Root 2 cancels out root 2. 2 cancels out 2. So I'm left with just x. And on this side, root 2 cancels out root 2. So just 1 up. So I have 1 out of 2. So the correct answer is D. D. 1 out of 2. Okay, question 12. Simplify 10 over square root of 32. Okay, so let's simplify 10 over the square root of 32. Okay, so I would rationalize, multiply both top and bottom by the square root of the denominator. Okay, so if I do that, I would have, or we could reduce the denominator first. Okay, so let's do that. All right, so let's just say this is something as saying 10 over root 16 times root 2, which would give me 10 over 4 root 2. All right, so now all I have to multiply by is root 2. So I'll multiply top and bottom by, to rationalize, I'll multiply top and bottom by root 2. Now, note that we are not changing the value by rationalizing. We're just multiplying by 1, because root 2 over root 2 is 1. Okay, so this would become 10 root 2 over 4 times 2. So root 2 times root 2 is 2. Okay, so next step would have 10 root 2 over 8. I think we can simplify this, because if I reduce this by 2, I would have 5 root 2 over 4, right? Because, 2 here is 5 and 2 here is 4, right? So that's 5 root 2 over 4. Yes, that's option A. That's option A. Okay, question 13. We have 2 root 3 minus 6 over root 3 plus 3 over root 27. We need to simplify this. Okay, so the first thing I'll do is I'll rationalize each term individually and then write them back in and see what we have. Okay, so let's do that. So this will be 2 root 3 minus, so 6 over root 3. To rationalize it, I'll just multiply top and bottom by root 3. That would leave me with 6 root 3 over 3, because root 3 times root 3 is 3, right? So this is just 2 root 3 also. Okay, plus, so let me rationalize this. So to rationalize 3 over root 27, I can multiply top. Okay, now let me rewrite root 27 first, right? Because I can actually simplify that. And this would be 3 over root 9 times root 3, which is 3 over 3 root 3, which is just 1 over root 3. I'm out of space. Okay, so let me do this here. Now, rationalizing 1 over root 3, I would have 1 over root 3 times root 3 over root 3, which just leaves me with root 3 over 3, right? Root 3 over 3. So you can play around with it and see if we arrive at the same place. So simplifying, 2 root 3 minus 2 root 3 just gives you 0. So we're left with root 3 over 3, which is option B. All right, that's option B. That's option B. Okay, that's 13. Okay, let's take 14. 14 is saying simplify 3 root 45 minus 12 root 5 minus or plus 16 root 20. Okay, so the first one is to simplify everything. All right, and see what we have, or if we have like terms that we can add up. All right, so 3 square root of 45 minus 12 square root of 5 plus 16 square root of 20. So 3 square root of 45, that would be 3 times the perfect square I can find in 45 is 9. So I'll write this as root 9 times root 5. This is already in the simplest form. The perfect square I can find in 20 is 4. That will be root 4 times root 5 gives you root 20. Okay, so this becomes 3 times 3 times root 5 minus 12 root 5 minus 16 times 2 root 5. So this is 9 root 5 minus 12 root 5 minus 32 root 5. 9 root 5 minus 12 root 5 would be minus 3 root 5. Oh, this is a plus, sorry. So minus 3 root 5 plus 32 root 5. This would give me 29 square root of 5. Right, so 29 square root of 5, that's option A. Okay, so I mistakenly wrote a minus sign, but I mean, everything else is good. All right, let's take on 15. Okay, question 15 says simplify half root 32 minus root 18 plus root 2. So half root 32 minus root 18 plus root 2. All right, so we'll just simplify, right? We'll have 1 over 2 times root 32 minus root 18 plus root 2. This will be 1 over 2 times root 32 is, I can drag out, the biggest square number I can drag out is 16, right? So times root 16 times root 2 minus biggest square number I can drag out from 18 is minus root 9 times root 2 and then plus root 2. So this will become 1 over 2 times 4 times root 2 minus 3 root 2 plus root 2. Simplifying this, I would have 2 root 2 minus 3 root 2 plus root 2. So I would have minus root 2 plus root 2, which is just what? 0. Which is just 0. That's D. All right, question 16. Okay, so we have 3 root 5 times 4 root 6 over 2 root 2 times 3 root 3. Okay, so we can just multiply out. The top would be 12 root 30. Okay, so you can multiply, when it's multiplication, it doesn't have to be like terms. So you can just go 3 times 3 for the value outside, and then root 5 times root 6 for the value under the root. Right, for the denominator I'll have 2 times 3 is 6 root 6. So same thing applies for division, right? So it's just going to be, no need for like terms, just 12 over 6 times square root of what? 30 over 6. Okay, so you can divide, the roots. So we'll end up with 2 and then square root of 5. That's option B. 2 square root of 5 is option B. Okay. Question 17 says simplify 5 over root 3 minus 3 over root 2. Okay, so the first thing is I'll rationalize each of them individually, then come back here and add them up like fractions. All right, so let me rationalize them. First, I will do 5 over root 3. I'll just multiply top and bottom by what? By root 3 over root 3. Okay, so I'm not changing the value of 5 over root 3, because if you think about it, I'm really just multiplying by 1, right? So this will be 5 root 3 over 3. All right, because root 3 times root 3 is 3. So we have 5 root 3 over 3 minus, let's take the next one, 3 over root 2 times what? Root 2 over root 2. This would give me 3 root 2 over 2. All right, minus 3 root 2 over 2. Okay, now we get to work. Our LCM is 6. 6 divided by 3 is 2. 2 times 5 root 3 is 10 root 3. Minus 6 divided by 2 is 3. 3 times 3 is 9. So that's 9 root 2, right? So the answer is 1 over 6, presenting it the way they did. Brackets 10 root 3 minus 9 root 3. And 9 root 2 rather, 9 root 2, sorry. So that's option B. Okay, question 18 says simplify square root of 188 plus square root of 125 minus square root of 75. Okay, so we'll just simplify here. The square root of 108 plus the square root of 125 minus the square root of 75. Okay, so the square root of 108, the biggest square number that we can drag out is 36. All right. Yes, so this will be square root of 36 times square root of 3 plus, but this is the biggest square number we can drag out is 25. Square root of 25 times square root of 3. And for this biggest square number we can drag out is 25. Oh, sorry. This is 5. Sorry. 25 times 5, yes, and this is now square root of 25 times square root of 3. Okay, Okay, good. So this becomes 6 root 3 plus 5 root 5 minus 5 root 3. Collecting like terms here means we can simplify this and this. 6 root 3 minus 5 root 3 will just give me root 3. Then plus what? 5 root 5. Plus 5 root 5. So that's question 18. That is E. So question 19 says simplify root 12 multiplying into root 48 minus root 3. Okay, so let me write that out. That will be root 12 multiplying into root 48 minus root 3. All right, so what does root 12 become? Root 12 can be simplified into root 4 times root 3, which should be 2 root 3. Right, 2 root 3. And then root 48 can be simplified into root 16 times root 3, which is 4 root 3. All right, 4 root 3 minus root 3. Okay, we can simplify what's in the bracket because they're like terms, so we can sum them up. So we'd have 2 root 3 and 3 root 3 in the bracket. Okay, we can go on and multiply. 2 times 3 is 6 root 3 times root 3 is 3, so the answer is 18. All right, so 2 times 3, multiplying the whole the coefficients, right? 2 times 3 is 6, and then root 3 times root 3 gives us 3. Multiply those, we have 18. Okay, question 20. Question 20, we have to simplify root 2, root 6 plus 2 root 2 minus 2 root 3. So first I would expand the bracket here. So I would have square root of 12 plus 2 times 2. All right, because when I take root 2 to multiply this, I mean the 2 is outside, but then root 2 times root 2 gives you 2. All right, then minus 2 root 3. Okay, so this will be let's simplify square root of 12. Square root of 12 simplifies to root 4 times root 3, which gives you 2 root 3. So we have 2 root 3 minus 4 minus 2 root 3. All right, so I can come in and cancel out this. Sorry, plus 4 rather. 2 times 6 plus 4, my bad. All right, so the correct option is C, positive 4. Okay, 21. Square root of 50 plus 10 over root 2. Okay, so let's simplify both of them, right? Root 50, let me simplify them first before I come to the work. Root 50 can be written as root 25 times root 2, because 25 is the biggest perfect square you can find, right? So this will just be 5 root 2. That means I really have just 5 root 2 plus, now 10 over root 2 can be simplified by multiply top and bottom by root 2, so rationalizing. Okay, so we're not changing the value of 10 root 2 by rationalizing here. I mean, root 2 over root 2 is 1, so you're literally multiplying by 1. What we are doing is we're changing how it looks. All right, so 10 root 2 would now look like 10 root 2 over 2, which would then give us 5 root 2. So it's 5 root 2 plus 5 root 2. You know, adding them up, we have what? 10 root 2. So the correct option is B. When 2 says 10 root 3 over root 5 minus root 15 squared. Okay, so I'm going to simplify, take out the sod first, and then we'll expand and see what, and see what comes out. Yeah. So we have 10 root 3 over root 5. I'll multiply, I'll rationalize this by multiplying top and bottom by root 5, right? I'm not changing the value, I'm just rewriting it. Okay, so if I do this, I would have 10 root 15 over 5, which is simply 2 root 15. So all of this here gave me 2 root 15. I rationalized, okay? I got rid of the denominator and simplified out. So that means that what we really have to work with, what they're asking us to really work with is, we really want to set up 2 root 15 minus root 15 all squared. So 2 root 15 minus root 15 will just leave you with root 15. And then you square root 15, you end up with 15. So the correct option is B. Okay, 23. 2 root 7 minus 14 root 7 plus 7 over root 21. Okay, so I'll simplify, rationalize the other two first before I make progress. So this will be 14 over root 7. To rationalize this, I would multiply both top and bottom by root 7 over root 7, which will give me 14 root 7 over 7, which just leaves me with 2 root 7, right? So that means that 14 over root 7 is actually 2 root 7 also. So that's done. Now let's take on 7 over root 21. Multiply top and bottom by root 21. Again, you need to understand that when you're rationalizing, you are not actually changing the value of, the previous value you're working with. Because multiplying by root 21 over root 21, like in this case, is just multiplying by 1, which doesn't change the value of what you're dealing with. All right, so this becomes 7 root 21 over 21. I think I can reduce that to give me 1 over 3 root 21. Okay, so let's fill in now. We have 2 root 7 minus, when we simplified 14 over root 7, we also got what? 2 root 7. Then plus, and when we simplified 7 over root 21, we got root 21 over 3. Okay, so this will cancel out this. We'll just be left with root 21 over 3, which is option C. Okay, question 24 says, simplify 3 root 12 plus 10 root 3 minus 6 over root 3. Okay, so let's simplify them one by one. 3 root 12 would be 3 times root 4 times root 3. The reason why is because 4 is the biggest perfect square we can bring out from 12. All right, so this would just be 6 root 3. Plus, next we have 10 root 3. Oh, 10 root 3 is fine, sorry. So 10 root 3 is just fine. It's 6 root 3 we need to worry about. And to simplify 6 over root 3, we have to rationalize, okay? So let's do that. So 6 over root 3, we'll rationalize by multiplying top and bottom by root 3. Now, when you do this, you're not changing the value of, the original 6 over root 3 you're dealing with, right? Because thinking about it, you're multiplying by root 3 over root 3, which is basically 1. All right, so the value stays the same. So this would just become 6 root 3 over 3, all right? Which can be better written as 2 root 3. All right, so minus 2 root 3. All right, so simplifying this, we end up with 16 root 3 minus 2 root 3, giving me 14 root 3. 14 root 3, that's option A. Okay, so the idea is just to simplify. Once you simplify, you would, it's just, collecting like terms and stuff. All right, 25. All right, 25 is same as 24. All right, so skip that. 26 says, which of the following is not a rational number? All right, so rational numbers are numbers that can be written as fractions. All right, fractions or whole number. Right, so a surd is not a rational number. Any square root that you cannot be simplified is not rational. All right, so this is a rational number because it can be written as 2. This is a rational number. This is a rational number because it's written as a fraction. The number that is not a rational number here is root 90, because you can't simplify root 90 to just a whole number or just a regular fraction. All right, so that's C. All right, final question. We have 20 over 5 root 28 minus 2 root 63. Okay, so the first thing I will simplify the denominator first, right? I would simplify the denominator first. So I have 5 square root of 28 minus 2 square root of 63. So let me do that here. This will be 5 times square root of 4 times square root of 7, okay? Because 4 is the highest square number that I can drag out from 28. Then minus 2 times square root of 9 times square root of 7. So 9 is the highest square number I can drag out from 63. So this will be 5 times 2 times root 7 minus 2 times 3 times root 7. So this gives me 10 root 7 minus 6 root 7, which gives me 4 root 7. Okay, I'm good checking my math. So we'll have 20 over everything here becomes 4 root 7. All right, now at this point I can rationalize what we have, right? I can rationalize what we have. I'll multiply top and bottom by square root of 7. Now, when you rationalize, you're not changing the value of what you're multiplying, because you're basically, just multiplying it by 1. We're taking advantage of the fact that root 7 times root 7 would give us just 7. So using that, we can clear out the unwanted denominator, right, of the surd in the denominator. So if we do that, we would have 20 root 7 over 4 times 7. Right, I can reduce 4, right? So like divide top and bottom by 4. So 4 here 1, 4 here 5. So the final answer is 5 root 7 over 7. All right, that's option B. All right, so thank you.